Hi, I'm Dr. Neenu Garg. In this session, I will discuss the preemptive version of shortest job first, and which is also termed as shortest remaining time first scheduling algorithm. So let's start. SRTF stands for shortest remaining time first algorithm. We know that SGF can be either preemptive or non-preemptive. The next CPU burst of the newly arrived process may be shorter than what is left of the currently executing process. For example, if there are two processes, P1 and P2 in the system, P1 arrives in the ready queue at 0 and P2 arrives in the ready queue at 1. These are the arrival times. And burst time of P1 is say 10. It needs 10 units of CPU time, and burst time of P2 is 2. Now if I plot a small Gantt chart here, at time 0, see, there is no choice, so P1 will execute till 1 time unit. At 1 time unit, P2 is also in system. The burst time of P1 remains 9. We know that it has completed its 1 unit of time on CPU. So this remaining burst time of already executing process is compared with the freshly arrived process which is in the ready state. And it is clearly visible that P2 has shortest next CPU burst. So CPU will be preempted and P2 will continue its execution. Okay, so P2 will execute till 3 because it has 2 CPU bursts and there is no more process which is arriving in the system. After that, P1 can continue its execution. So this is how things work in preemptive SGF. Okay. Another important point that I want to mention is SRTF. Please note that SRTF behaves like SJF when all processes have arrived in the all processes have arrived in system. So we will understand this point with the when we do numerical that, but you should remember, just learn this thing that SRTF behaves like SJF when all processes arrive in the system. So what we have learned, if the SJF algorithm is preemptive, it will preempt the currently executing process if its next CPU burst is longer than that of the process that arrives. Non-preemptive SGF algorithm, it will allow the process to finish. If this could have been the case of non-preemptive, in this case, when P2 arrives in the system at 1, CPU will not be preempted from P1. It will keep on executing P1 because when P1 was scheduled at that time, there was only one process. So CPU will not be preempted. If you want to see the example of non-preemptive SJF algorithm, then please refer the video SJF example. The numerical problem solved there is the non-preemptive scheduling algorithm. And we have already discussed that preemptive SJF scheduling algorithm is known as shortest remaining time first algorithm. Short form is SRTF. Now let's understand SRTF scheduling algorithm and we will find average turnaround time and average waiting time. Okay. So we will first plot Gantt chart. We'll start with time 0. At time 0, process P1 came in the system. Since there is no other process at time 0, so P1 is scheduled by the scheduler. P1 will execute. At time 1, the remaining burst time of P1 is now 7 and P2 has also arrived in the system. Now what scheduler will do in SRTF scheduling algorithm, scheduler will compare the burst time, the pending burst time of the process which is in execution with the burst time of the newly arrived process, which is in this case it's 4 and 4 is less than 7, so CPU will be preempted from P1. and it will start executing the process P2. At time 2, the burst time of P2 remains 3 and P3 has also arrived in the system. Now there are three choices, P1, P2 and P3. So among all these processes, P2 has the shortest next CPU burst time. So CPU will not be preempted and it will keep on executing. If you can observe, P2's burst time will remain shorter than the other processes that are going to arrive. Right? This we can see because we are able to see all the processes on the screen. Okay. So at time 3, its burst time is 2. At time 3, P4 also arrives. Now all the four processes are there in the system. What scheduler will do? Now scheduler will see the burst times. P2 still has the shortest burst time, and as the important point that was discussed, now all the processes have arrived, so Srtf will behave as SJF. P2 will continue to execute and P2 will finish its execution at 5. It will execute for 2 more units because its burst time was 2 units pending. Okay. So P2 is done. We are left with P1, P3 and P4. Among these three processes, P4 has the shortest burst time. So P4 will be scheduled and it will execute till 10. Okay. An important point to note is if any other process P5 arrives in the system whose burst time is less than the remaining burst time of P4, CPU will be again preempted. Okay. But no more process arrive in the system between 5 to 10. So P4 will complete its CPU burst. Now P4 is also done. Now only two processes are left, P1 and P3. Clearly, P1 has shorter burst time than P3. So P1 will execute till 17 and P1 is done. Finally, P3 will be scheduled and it will execute till 26. P3, yes, right? So now we will find these times. CT is completion time, turnaround time, and this is waiting time. So from Gantt chart, we can easily find out completion time of P1. It is now 17. Yes, quickly. P2's completion time is 5. P3 is 26. And P4's it's 10. Turnaround time. We know that turnaround time is completion time minus arrival time. For P1, completion time is 17, arrival is 0. So turnaround time is 17. For P2, completion time 5, arrival time 1. So its turnaround time is 4. For P3, completion time is 26, arrival time is 2. That gives turnaround time to be 24. For P4, completion time is 10, arrival time is 3. So it remain in the system for 7 time units. Okay. Yes. Now waiting. So yes, we have to find average turnaround time. We'll find it here only. 17 plus 4 plus 24 plus 7 divided by 4 because the number of processes is 4. So this is an activity for you. You have to find it on your own. I have written here x milliseconds. Okay, you can find out this value. Now let's find the waiting time. Waiting time is turnaround time minus burst time. For P1, turnaround time is 17 and burst time is 8, which is uh, 9. The waiting time is 9. Next, for P2, turnaround time is 4 and burst time is 4, which is 0. You can verify this time from graph as well, Gantt chart as well. P2 arrives at time 1 and it complete its execution. It was not preempted during its execution. It leaves the CPU at 4. it never waits for CPU. As soon as it arrives, it gets the CPU and then it leaves the CPU when it was terminated. Obviously, its waiting time is 0. So you will mark here 0. For P3, turnaround time is 24 and its burst time is 9. So that gives me 15. So waiting time is 15. For P4, turnaround time is 7, burst time is 5. So the waiting time is 2. So if you calculate the average, that gives you 9 plus 0 plus 15 plus 2 divided by 4. Again, it is an activity for you. You will find on your own. You can find the average waiting time like this. So I hope the concept of Srtf scheduling algorithm is clear. Okay, thank you.